Hello everyone, we are back on solving questions with pros and experts. Let's see the next question. A stable and causal LTI system produces an output y of n equal to n 4 by 5 to the power n u of n for the excitation, that means input x of n equal to 4 by 5 to the power n u of n. Using DTFT, question A, determine the frequency response of the system. And question B, derive the difference equation relating the input and output. So, you have to find out frequency response of the system, which is nothing but h of e raised to j omega, and that is given by the ratio of output DTFT divided by input DTFT, y of e raised to j omega by x of e raised to j omega, and y of n is given as n into 4 by 4 raised to n u of n, and x of n is given as 4 by 5 raised to n u of n. So you can easily find out y of e raised to j omega and x of e raised to j omega. Find the ratio, you will get the frequency response. So first you can find out the Fourier transform of x of n, that is x of e raised to j omega, and you are given x of n as 4 by 5 raised to n u of n. Okay, and if you are good with the DTFT, you might be knowing a standard result as if x of n is of the form alpha raised to n u of n, then the DTFT is given by DTFT of x of n given by x of e raised to j omega. You can equate it to 1 by 1 minus alpha e raised to minus j omega. Okay, so here in the question, our x of n is of the form alpha raised to n u of n. So directly we can write the Fourier transform of DTFT of x of n as x of e raised to j omega equal to 1 by 1 minus 4 by 5 e raised to minus j omega. Okay, so we have easily found out x of e raised to j omega. Now what we have to find out is y of e raised to j omega, that means the Fourier transform of y of n. Now listen, how they have framed the question is such that x of n is 4 by 4 raised to n u of n and y of n is n into 4 by 4 raised to n u of n. That means n into x of n, right? This is x of n, so y of n is n into x of n. That's clear. Now what we have to remember here is one property of discrete time Fourier transform, which says that, listen very carefully, which says that if x of n is having a discrete time Fourier transform x of e raised to j omega, then minus j into n into x of n will be having a discrete time Fourier transform, which will be d by d omega of x of e raised to j omega. Okay, and we call it the differentiation frequency property of DTFT. This is the differentiation frequency property of DTFT. This is the main takeaway in this question. So we can say that our aim is to find out the Fourier transform of n into 4 by 4 raised to n u of n, but minus j into n into x of n is having Fourier transform differentiation. Okay, so I can write minus j into n into 4 by 5 raised to n u of n will be having a DTFT. What it will be? D by d omega of x of e raised to j omega, right? What is x of e raised to j omega? We have found it as 1 by 1 minus 4 by 5 e raised to minus j omega. So d by d omega of 1 by 1 minus 4 by 5 e raised to minus j omega. And what will be the value? I can write in the next step. Therefore, DTFT of we have to find out only n into 4 by 4 raised to n of n. No need of this minus j. Okay, so for a transform of n into 4 by 5 to the power n u of n, you will get it as I can according to linearity property, I can bring this minus j to the denominator in this side. Okay, so minus 1 by j into d by d omega of 1 by 1 minus 4 by 5 e raised to minus j omega. Okay, and it turns out to be minus 1 by j into minus 1 by 1 minus 4 by 5 e raised to minus j omega the whole square. The differential is not over. You have to find out the derivative of this denominator term also. Okay, and that turns out to be 0 minus 4 by 5 e raised to minus j omega. Again, it is not over. We have to find out the derivative of minus j omega also, and that is nothing but minus j. Okay, and now we can see a lot many terms cancelling there. I can take this to negative f positive. Here also we can have positive, and there is a j and j cancelling here. So Fourier transform of listen, n into 4 by 4 raised to n u of n is nothing but y of n. So Fourier transform of y of n, you can write it as y of n. The Fourier transform of y of n is y of e raised to j omega. So y of e raised to j omega is straight away obtained as 4 by 5 e raised to minus j omega whole divided by 1 minus 4 by 5 e raised to minus j omega the whole square. Okay, so very beautifully we have obtained x of e raised to j omega and y of e raised to j omega. So question A can be easily answered as x of e raised to j omega is the ratio of y of e raised to j omega and x of e raised to j omega. That means therefore h of e raised to j omega is equal to y of e raised to j omega divided by x of e raised to j omega, and you will get it as x of e raised to j omega is from this equation it is 1 by 1 minus 4 by 5 e raised to minus j omega whole divided by sorry it is just the opposite, y of e raised to j omega by x of e raised to j omega. Sorry, I'm so sorry for that. So y of e raised to j omega is this thing, 4 by 5 e raised to minus j omega divided by 1 minus 4 by 5 e raised to minus j omega the whole square whole divided by, now x of e raised to omega is to be written, that is 1 by 1 minus 4 by 5 e raised to minus j omega, and we can have this cancel, one factor cancels. That implies h of e raised to j omega, or the frequency response, is equal to 4 by 5 e raised to minus j omega whole divided by 1 minus 4 by 5 e raised to minus j omega. So that turns out to be the answer to question A, part A. Okay. And now what part B of this question is asking you to find out is the difference equation representation. Difference equation representation pertaining to this system. What is difference equation? Difference equation is very much like a differential equation, but it is an input-output relation for a discrete time system, like y of n minus y of n minus 1 or 2 minus y of n minus 1 is equal to x of n plus half x of n minus 1. This is a difference equation. Okay, so you have to obtain a difference equation for this system, and what you know is h of e raised to j omega. Okay, so we can start from the scratch. H of e raised to j omega is nothing but y of e raised to j omega divided by x of e raised to j omega, and that is obtained as 4 by 5 e raised to minus j omega whole divided by 1 minus 4 by 5 e raised to minus j omega. Okay, so whenever you are asked to find out the difference equation, you always adopt this procedure. You just cross multiply the factors. Okay, so y of e raised to j omega into 1 minus 4 by 5 e raised to minus j omega will be equal to x of e raised to j omega into 4 by 5 e raised to minus j omega. So I can write it as cross multiplying. I can write it as y of e raised to j omega into 1 minus 4 by 5 e raised to minus j omega is equal to 4 by 5 into e raised to minus j omega into x of e raised to j omega. Okay, so we got an equation like this. Okay, and now I can take one more step to bring y of e raised to j omega into the bracket. So that implies y of e raised to j omega minus 4 by 5 e raised to minus j omega will be equal to 4 by 5 e raised to minus j omega into x of e raised to j omega. Okay, now what I am asking you to do is just to take the inverse DTFT. Just take inverse DTFT on both sides of this equation, and what you will get is, what is the inverse DTFT of y of e raised to j omega? It is y of n. So y of n minus 4 by 5 can be written as such because of linearity. It will not affect. What is the inverse transform of, did I miss a y of e raised to j omega here? Okay, sorry, y of e raised to j omega, when you take into the bracket, here also it will come, right? So it's a slight mistake. Here also y of e raised to j omega equal to, okay, fine. Okay, so let us turn back to the finding inverse transform. So inverse transform of y of e raised to j omega is y of n. And what is the inverse transform of 4 by 5 e raised to minus j omega y of e raised to j omega? Actually, y of e raised to j omega, when you calculate the inverse transform, you will get it as y of n. And what about e raised to minus j omega into y of e raised to j omega? The inverse transform will be y of n minus 1. It is nothing but the time shift property of DTFT. Time shift property means when you are shifting one unit in the time, you have to multiply with an exponential, e raised to minus j omega. Okay, if at all it was y of n minus 2, then e raised to minus j omega into 2. Okay, that is the only difference. So with respect to this result, I can write it as 4 by 5 into y of n minus 1 equal to, in the RHS again we are taking the inverse transform. So 4 by 5 into e raised to minus j omega x of e raised to j omega. Its inverse transform will turn out to be x of n minus 1. Again, it is a time shift property of Fourier transform. Okay, so what we have obtained is a difference equation representation of our system. Okay, so that's the answer to the part B also. There completes the question. So there comes the next question. Using Z transform, determine the output of an LTI system with impulse response h of n for the input x of n. So the concept behind this question will be very clear to you because it is a very important one. We have started this concept right from the first module, where we can see it is an LTI system. You are required to find out the output of this system, and you are given the impulse response. So what will be the output? It is nothing but convolution sum. Okay, it is convolution sum. But here the only difference is we are asked to find out this convolution sum in a Z transform environment. So what we have to take is, we are given h of n, find out h of z, the Z transform of h of n. Okay, then we are given x of n also, find out x of z, which is nothing but its Z transform. And what will be y of n? Y of n equal to x of n convolution h of n. Okay, but when you take out the Z transform of this equation on both sides, it will be y of z equal to x of z into h of z. You will know this. Okay, so from this you have you can have h of z here, x of z here. You can multiply both of this and you will get y of z, and take the inverse transform, you will receive at the answer. Okay, so that's the logic behind this question. So let us try to find out the Z transform of h of n first. Okay, h of n is given as 1, 2, minus 1, 0, and 3. Okay, and we can assume 1 starts at n equal to 0. Okay, so this sample is at n equal to 0, so I can write h of 0 equal to 1. H of 0 equal to 1, right? First sample at n equal to 0 starts with this sample, so h of 0 equal to 1. What is h of 1? H of 1 will be the next sample, 2. Okay, h of 2 equal to minus 1, h of 3 equal to 0, and h of 4 equal to 3. Okay, And that's very clear. Similarly, or you can from this data we can find out h of z. What is h of z? You know the expression for z transform. X of z for a signal x of n is given by sigma n equal to minus infinity to infinity x of n z raised to minus n. Okay, so here it will be sigma n equal to minus infinity to plus infinity h of n z raised to minus n. Okay, but the signal is only existing from n equal to 0 to n equal to 4. Okay, n equal to 0, 1, 2, 3 up to n equal to 4. So this sigma becomes sigma n equal to 0 to 4 h of n 0 to minus n. Okay, and the only way behind us is to expand the sigma, and we can do that. That becomes h of 0 into z raised to minus 0 plus putting n equal to 1, h of 1 into z raised to minus 1, n equal to 2 becomes h of 2 z raised to minus 2, h of 2 z raised to minus 2 plus h of 3 z raised to minus 3 plus h of 4 z raised to minus 4. I can have a bit request. Whenever you write or solve problems in signals and systems, especially from this area, Z transform area, if you write 2 like this and Z like this, write like this, in some steps you may get confused about whether you're writing a 2 or a Z. So it's a recommendation, always try to write 2 like this and Z like this. Also avoid writing Z like this, because at some point of time you will confuse it with 3, numerical 3. So this is a slight recommendation out of experience. I'm saying that you may be facing some confusion like this. So always try to write 2 like this and Z like this. Okay. Okay. So this is equal to, what is h of 0? H of 0 is 1. So 1 into z raised to 0 is 1 itself, 1 plus, what is h of 1? H of 1 is 2. So 2 into z raised to minus 1 plus, what is h of 2? H of 2 is minus 1. So it is minus z raised to minus 2 plus h of 3 equal to 0. So that term becomes 0, and h of 4 is 3. So 3 into z raised to minus 4. So this is the Z transform of h of z. H of n. That means h of z. Okay. Now, similarly, we can calculate the Z transform of x of n, where x of n is given as, in the question, it is 1, 2, minus 1. Again, let us assume that n equal to 0 sample will be 1, or the signal starts at n equal to 0. So x of 0 is equal to 1, x of 1 equal to 2, and x of 2 equal to minus 1. Therefore, what is the Z transform of x of n? X of z will be equal to sigma n equal to 0 to 2 x of n 0 raised to minus n. Okay, actually this summation is from minus infinity to plus infinity, but since x of n is only available in n equal to 0, 1 and 2, we can sum it like this. Okay, so expanding the summation, just x of 0 into 0 raised to 0 is 1 plus x of 1 into 0 raised to minus 1 plus x of 2 into 0 raised to minus 2. Okay, right, so that will give you x of z as, x of 0 is given as 1, so 1 plus x of 1 is 2, so 2 into 0 raised to minus 1 plus x of 2 equal to minus 0 raised to minus 2. Okay, so we got h of z and x of z. Okay, and the question is to find out the output. So we have to find out y of z, right? We have to find out y of z. Okay, so from taking the Z transform of convolution property, y of z is equal to h of z into x of z. Okay, and okay, h of z is given as, we can write once more 1 plus 2z inverse minus z inverse 2 plus 3z inverse 4. And x of z is equal to 1 plus 2z inverse minus z inverse 2. Let us try to find out y of z. We can multiply 1 this like this. So 1 plus 2z inverse minus z inverse 2. Okay. Plus, now we can multiply like this. 2z inverse plus 4z inverse 2 minus 2z inverse 3, then minus z inverse 2 minus 2z inverse 3 plus z inverse 4. Okay, plus 3z inverse 4 plus 6z inverse 5 minus 3z inverse 6. Okay, this might be the output, the product. So 1 plus, we can do 2z inverse here, 2z inverse here, so 4z inverse. Okay, so 4z inverse, then minus z inverse 2 plus 4z inverse 2 minus z inverse 2. So 4 minus 2 is plus 2z inverse 2. Okay, now we have minus 2z inverse 3 minus 2z inverse 3 is minus 4z inverse 3, correct? And we have plus z inverse 4 plus 3z inverse 4, which will turn out to be plus 4z inverse 4. Then these two terms, plus 6z inverse 5 minus 3z inverse 6. Okay, so this is y of z. This is y of z, but the problem is not over. We have to find out y of n. So what is y of n? What is y of n? Now can you find out y of n? Just take the inverse Z transform. Okay, so inverse Z transform of 1 is, or we can write 1 as 1 into, you can imagine this 1 as 1 into z raised to 0. Okay, or you can listen to what we have already done. Here 1, 2, minus 1 was a signal. The transform of 1 plus 2z inverse minus 2z inverse 2. Okay, so here the coefficient was the first sample, the coefficient of the second term the second sample, and minus 1 the third sample. Okay, similarly what we can do is, here this 1 will be the first sample. So 1 comma, then 4, 2, minus 4, 4, 6, minus 3. Okay, so this is the output signal y of n. Okay, let's start the next question. Determine the discrete time Fourier transform of x of n equal to half raised to n sine n pi by 4 of n. So x of n is equal to half to the power n sine n pi by 4 into u of n. So on a single glance, we don't have any direct relations that will fetch the Fourier transform of this signal. So we have to rearrange the signal in some way or other that may give us a valid Fourier transform or a non-result. So the problem that I face in the signal is nothing but the presence of sine n pi by 4. That's clear, because if it was half raised to n u of n, I had a ready-made DTFT. I could have just applied it and obtained the transform, but this presence of this sine n pi by 4 is the problem. So what I have to do is I have to reform that sine n pi by 4 in some other way, and the best method is write it as e raised to j n pi by 4 minus e raised to minus j n pi by 4 whole divided by 2j into u of n. Okay, this is how I can rewrite sine n pi by 4. Okay, so that becomes, you can write it as 1 by 2j into half raised to n into e raised to j n pi by 4 u of n minus, again 1 by 2j, 1 by 2j is common to the brackets, so 1 by 2j into e raised to minus j n pi by 4 into half raised to n u of n. Okay, that's correct. Let me rearrange this thing. E raised to j n pi by 4 into half raised to n. I can write it like that. That may be a bit convenient. So this is e raised to j n pi by 4 into half raised to n. Both the same, but for some convenience, I'm writing like this. Okay. Now this is my x of n. Okay, this is my x of n. Let this be equation number 1. We need it. Now let me invite your attention to some results you have in this three-term Fourier transform. It is just nothing but half raised to n u of n. I can write it in another ring. Half raised to n u of n, that is having a Fourier transform DTFT. It is a standard result, which is nothing but 1 by 1 minus half e raised to minus j omega. It is a standard result. That is a standard result we know. Okay. And also, if at all, if half raised to n u of n, or I can write, if x of n is having a discrete time Fourier transform x of e raised to j omega, then what is the Fourier transform of e raised to j n omega 0 into x of n? What will be that? It would be frequency shift, right? So x of e raised to j into omega minus omega 0, right? So this is nothing but frequency shifting. Therefore I can write it as e raised to j n pi by 4 into half raised to n u of n will be having a discrete time Fourier transform. Why did I take like this? Because nothing but in the first term you have a term like that, a factor like that, e raised to j n pi by 4 into half raised to n u of n. That's what I have taken here. So using the same property of frequency shifting, I can write this as 1 by 1 minus half e raised to minus j into frequency shifting. Wherever you find omega, you shift omega by omega minus pi by 4, because here in the place of omega 0, which is being shifted with the omega, so in place of omega 0 we have pi by 4, right? E raised to j n omega 0 is replaced by e raised to j n pi by 4. So I can write it as omega minus pi by 4. Okay, so that's the DTFT of the first term, and there's a scaling factor 1 by 2j. We will add that later. And similarly I can write what is the Fourier transform or discrete time Fourier transform of e raised to minus j n pi by 4 into half raised to n u of n. That would be 1 by 1 minus half e raised to minus j into, instead of omega, it is omega plus pi by 4. Okay, so we have applied again frequency shift property, because here it is positive pi by 4, here it is minus pi by 4. So here it was omega minus pi by 4, here it should be omega plus pi by 4. Okay. So we have obtained the Fourier transform of both these terms except the scaling factors. Now we can add now we can take equation number 1. Therefore, taking equation number 1 and finding DTFT on both sides. So x of e raised to j omega, that is what we have to find out in the question. That is equal to 1 by 2j into, what is the Fourier transform of this thing that was obtained in equation, this equation, I can name it as equation number 2. This is equation number 3. Okay, so from equation number 2 I can write it as 1 by 1 minus half e raised to minus j omega minus pi by 4. Okay, right, minus 1 by 2j, second term is 1 by 2j into what is the Fourier transform of e raised to minus j and pi by 4 half raised to n u of n? That is obtained in equation number 3. That is obtained in equation number 3. So I can write it as 1 by 1 minus half e raised to minus j into omega plus pi by 4. There's no any other difference. Okay, so we have got an expression for x of e raised to j omega, which is a little bit bulky. So what you need to do is just simplify it. All that matters is simplification. Okay, so that is equal to, I can take 1 by 2j common, and that is 1 by 1 minus half e raised to minus I can split, or I can expand this bracket. Sorry, I can expand this bracket, so that will give you e raised to plus j pi by 4 into e raised to minus j omega. Okay, e raised to plus j pi by 4 into e raised to minus j omega, correct. And minus of 1 by 2j is already taken out, so 1 by 1 minus half e raised to minus j pi by 4 into e raised to minus j omega. Okay, now let us see, let us take the LCM and simplify. So this thing becomes 1 minus half e raised to minus j pi by 4 e raised to minus j omega, right? I have taken this term to here, cross multiplication. Likewise, I will do this term to here, minus of. Okay, so minus of 1 plus, there's a minus here, so minus 1 plus, it becomes plus. Minus 1 plus half e raised to j pi by 4 into e raised to minus j omega, whole divided by product of the denominators, separate denominators. That will give you 1 minus half e raised to j pi by 4 e raised to minus j omega multiplied with 1 minus half e raised to minus j pi by 4 e raised to minus j omega. Okay, so readily we can cancel out this thing. That implies 1 by 2j into, in the numerator I have the privilege to take out 1 by 2 e raised to minus j omega in common in both sides, or in both terms, right? So the remaining is e raised to minus j omega here minus e raised to I'm sorry I've taken e raised to minus j omega, right? So okay, so e raised to minus j omega, half e raised to minus j omega is taken out, so remaining is e raised to j pi by 4 in this term minus e raised to minus j pi by 4 in this term. Okay, so that divide by, now I can what I can do with the denominator is I can multiply throughout. Okay, so it becomes 1 minus half e raised to j pi by 4 e raised to minus j omega, okay, minus half e raised to minus j pi by 4 e raised to minus j omega plus 1 by 4 e raised to j pi by 4 multiplied by e raised to minus j pi by 4 will give you 1, and e raised to minus j omega into e raised to minus j omega will give you e raised to minus j 2 omega. Okay, so that is the expansion. Now what happens is this is equal to 1 by 2j into 1 by 2 e raised to minus j omega into what is e raised to j pi by 4 minus e raised to minus j pi by 4? It is cos, it is actually it is sine, right? E raised to j pi by 4 minus e raised to minus j pi by 4 is sine. And it is not just sine, it is 2j sine pi by 4. 2j sine pi by 4. You know the reason, right? Do I need to refresh that? Okay, I can just roughly say that because e raised to j theta equal to cos theta plus j sine theta, e raised to minus j theta equal to cos theta minus j sine theta. So whenever I subtract this equation minus this equation, I will get e raised to j theta minus e raised to minus j theta equal to 2j sine theta. Okay, that's what I'm getting here. E raised to j pi by 4 minus e raised to minus j pi by 4 will give you 2j sine pi by 4. That's I have written here. Okay, so there was a quick reminding those who have started watching the videos the late, they can find it helpful. Okay, so this is 2j sine pi by 4 whole divide by whole divide by 1. I'm taking this term 1 plus 1 by 4 e raised to minus j2 omega. Okay, now the remaining terms are this term and this term, and from both of this term I can take out minus half e raised to minus j omega. Okay, so what remains is e raised to j pi by 4 plus e raised to minus j pi by 4. Okay, so this becomes I can cancel out 2j and 2j, right? And what is sine pi by 4? Sine pi by 4 is 1 by root 2. Okay, so in the numerator I can write it as 1 by 2 root 2 e raised to minus j omega. Why? Because there's a 1 by 2 already here, and sine pi by 4 will give you 1 by root 2, so it is 1 by 2 root 2, and e raised to minus j omega is already there. Okay, whole divide by 1 plus 1 by 4 e raised to minus j2 omega minus half e raised to minus j omega into what is e raised to j theta plus e raised to minus j theta. Here is of the form e raised to j theta plus e raised to minus j theta. That is nothing but 2 cos theta. So instead of theta, it is 2 cos pi by 4. So into 2 cos pi by 4. And that is equal to 1 by 2 root 2 e raised to minus j omega whole divide by 1 plus 1 by 4 e raised to minus j2 omega, and this is 1 by minus 1 by 2 e raised to minus j omega into what is cos pi by 4? That is again 1 by root 2, right? Right, so this is 1 by root 2 into 2. This is 2 cos pi by 4, right? So 2 by root 2. 2 into 1 by root 2. Okay, and cancel 2. So this is equal to 1 by 2 root 2 e raised to minus j omega whole divide by 1 plus 1 by 4 e raised to minus j2 omega minus 1 by root 2 e raised to minus j omega. I think we can stop here. There's no need to simplify it further. So this could be the final answer. Okay, we will see the next question. This is an asked question. Compute the Z transform and ROC of the signal x of n equal to half raised to n of minus n minus 2 raised to n of minus n minus 1. Also, plot the pole 0 pattern. It's an 8-mark question. So, given signal has two terms or two signals, two subsignals. First one is half raised to n u of minus n, and second one is minus 2 raised to n u of minus n minus 1. You have to find the Z transform, then find the ROC and plot the pole 0 pattern. So let us see the first term, half raised to n u of minus n. Do we have any straightaway questions to find out the Z transform of this signal? The answer is straightaway no. because if at all it was half raised to n u of n, you could have written. Or if at all if it was half raised to n u of minus n minus 1, that is the same Z transform, but it's a left-sided signal. Again, you could have written. But this is half raised to n u of minus n. So either you have to apply some property, or you can start from the scratch. You can apply, that means you can apply directly the definition of Z transform. So here application of properties is a bit confusing or a bit hard. So let me move on to taking the definition of Z transform. So what is the definition of Z transform? X of Z is equal to sigma n equal to minus infinity to plus infinity x of n z raised to minus n. Okay, so I'm taking this signal known as x1 of n, and this signal known as x2 of n. Okay, all right. So what is x1 of z? I can start calculating x1 of z as sigma n equal to minus infinity to plus infinity x1 of n, right? x1 of n into, that means half raised to n u of minus n into z raised to minus n. Now a little intuition into the signal will reveal you that this signal is a left-sided signal, right? The signal is half raised to n multiplied by u of minus n. That means this is half raised to n. This is half raised to n. It's a decaying exponential signal in discrete time domain, and that is being multiplied with what? U of minus n. U of minus n is a reflected version of u of n. So it starts from 0, minus 1, minus 2, etc. goes to infinity, minus infinity. Both these signals goes to minus infinity. Both these signals go to minus infinity. Okay. So what is the product of these two signals? Half raised to n multiplied by u of minus n will remove all these positive values, right? Positive samples, because in that time u of minus n is 0. Okay. So this is an entirely left-sided signal. You can see the product is entirely a left-sided signal. So as consequently, I can reduce this sigma as n equal to 0 to minus infinity. That will be right? N equal to 0, minus 1, minus 2, extra up to minus infinity. There is no any positive n values. So the sigma is, I can modify it as n equal to 0 to minus infinity, half raised to n, z raised to minus n. I don't need to write u of minus n again, because the effect of u of minus n has made the signal to truncate from 0 to minus infinity. So I don't need to write u of minus n again. So half raised to n, 0 raised to minus n. So this is equal to I can write as sigma n, or I can expand the summation right now. Remember, the summation is from 0, minus 1, minus 2, etc. up to minus infinity. Okay, I can, for convenience, I can club this half raised to n, 0 raised to minus n as half raised to n is actually 1 by 2 raised to n. Z raised to minus n is actually z raised to n. So this is nothing but, let me rub this off. So this is nothing but sigma n equal to 0 to minus infinity 1 by 2z to the power n. Okay, 1 by 2z to the power n. And on expanding, first put n equal to 0, right? N equal to 0. So 1 by 2z raised to 0 is 1. Anything raised to 0 is 1. Plus, what is the next n value? Next n value is n equal to, not n equal to 1, but n equal to minus 1. That is where you have to be concentrated about, right? N equal to 0 to minus infinity is the sigma. So after n equal to 0, next value will be n equal to minus 1. So putting n equal to minus 1, this will be equal to 1 by 2z raised to minus 1, which is equal to 2z itself, right? 1 by 2z raised to minus 1 will be equal to 2z itself. Okay, you know that. So on, we can write next value will be 2z raised to minus 2. 1 by 2z raised to minus 2, which will give you 2z raised to 2 plus etc. and goes to infinity. Okay, and what will be the answer or the result of this summation? it is nothing but a GP. So the summation result will be a by 1 minus r. As you know, we have done it several times in the module 1. So this is equal to 1 by 1 minus versus r is nothing but 2z. Okay, so 1 by 1 minus 2z, but you have to take care that that's an assumption. This a by 1 minus r is valid only if mod r is less than 1. The common ratio should be less than 1. So I can write it as, the condition is common ratio is 2z. So mod of 2z should be less than 1. Okay, I'm saving this here. I have to use it later. So x1 of z is 1 by 1 minus 2z. Okay, 1 by 1 minus 2z. Okay, or I can write it as, let me take 2 outside, 1 by 2 into half minus z. Okay, or this is equal to minus half divided by z minus half. Okay, so this is the z transform. x1 of z is equal to minus half divided by z minus half. What is the ROC? The question clearly mentions to find out ROC. So what is ROC? ROC can be found out from this saving, right? Here the condition is mod 2z less than 1. So what is mod z? Mod z will be less than 1 by 2. Okay, so ROC is mod z less than half. Clearly half is the pole of this z transform. So mod z less than half is the ROC. So that's how you get x1 of z. Now similarly, you have to find out x2 of z, where x2 of z is already taken as 2 raised to n u of minus n minus 1. Okay. Now x2 of n is equal to 2 raised to n u of minus n minus 1. So now we can write down the z transform of this signal straight away, because you know 2 raised to n u of n and minus 2 raised to n u of minus n minus 1 will have the same z transform, that will be equal to z by z minus 2. But the specialty is this signal is left-sided signal, so the the ROC will be mod z less than 2, right? Mod z less than 2. Okay, so we can write x2 of n is 2 raised to n u of minus n minus 1. Therefore x2 of z is equal to minus, here you have to remember that minus 2 raised to n u of n minus 1 will be having z by z minus 2. So plus 2 raised to n u of minus n minus 1 will be having minus z by z minus 2. So I am putting minus z by z minus 2. And ROC, what is ROC? ROC is mod z less than 2. Okay, so we got x1 of z as this thing and x2 of z as this thing, and the ROC of both the transform, individual transform. So finally x of z will be having, we know x of n equal to x1 of n plus x2 of n. We have put it in the first step. So x of z will be equal to x1 of z plus x2 of z, which will give you x1 of z is minus half divided by z minus half plus x2 of z is minus z by z minus 2. Okay, or in fairly I can write as minus 1 by 2 by z minus half minus z by z minus 2. This is the z transform. And what is ROC? Always remember, whenever you write Laplace transform or z transform, specify the ROC. What is ROC? ROC for first transform, it is mod z less than half. For the second transform, it is mod z less than 2. So what is the ROC for the combined z transform? It will be the intersection of both this individual ROCs. Okay, intersection. And how can you write the intersection? We can write the intersection as the I can write it fairly. ROC is actually mod z less than half intersection mod z less than 2. This is what we need to plot. Okay, so let us try to plot this. Okay, I have drawn the z plane with the real part of z in the x-axis and imaginary parts of z in the y-axis. And so this is the pole. Okay, this is the first pole, z equal to half. Okay, first pole z equal to half. And the next pole is z equal to 2. That is obvious from your transform equation, z equal to 2. Alright, so and I have drawn circles, 2 circles corresponding to both these poles. And our ROC, first ROC is mod z less than half. How will mod z less than half appear? Mod z less than half will be mod z less than half, because this signal corresponding to this term is left sided. So that's why we have got the ROC as mod z less than half. So mod z less than half was this ROC is the portion, this portion where it covers the circle inner to the pole, right? Pole is 1 by 2. Okay, so the circle inner to the pole, that is the special for a left sided signal. Always left sided signal will be having ROC like this, inner to the innermost pole or inner to the pole. Okay, so this is the ROC corresponding to mod z less than half. Now there is one more term, you can see one more term, which is minus z by z minus 2, whose pole is at 2, right? Pole is at 2. And again here also the signal was a left sided signal. From the question it is very clear that both these signals were left sided. So the signal corresponding to this pole also is left sided. That's why we have obtained mod z less than 2. And how will you draw mod z less than 2? It is the region in the circle inner to the corresponding pole. Corresponding pole is 2, so the circle inner to this pole. Okay, because this is again a left sided signal. So whatever you see inside the circle will give you ROC for the second term. ROC corresponding to the pole z equal to 2. That is mod z less than half, mod z less than 2. Okay, so this is it. Now, so I have shaded in green the ROC corresponding to the first term alone, and I have shaded in blue ROC corresponding to the second term alone. Now my question is, or I have to find out the ROC corresponding to the both terms. I mean the entire Z transform, that is the intersection. What is the intersection? Intersection is nothing but intersection of mod z less than half and mod z less than 2 is nothing but this circle, right? Nothing but this circle, right? So I can shade this circle as the intersection, and that what is the expression for this circle? The circle is nothing but mod z less than half. Okay, mod z less than half. So both the ROCs intersect at the circle which is mod z less than half. So this is the ROC. Okay. So I can write ROC is mod z less than half. So we got the Z transform here and the total ROC. Also the a question has asked us to find out the pole 0 pattern, and I have already marked the poles. Mod z is equal to half and mod z equal to 2. And what is the 0? You could have identified poles directly from this equation, this partial fraction equation, but for zeros you cannot identify at a glance and a single glance from this equation. For that we have to find the LCM and simplify. I'm leaving it to you, that work I'm leaving it to you. It's a very trivial work. So when you find out the 0, it will be having a single 0 at z equal to 0.5 plus j root of 3 by 4 or 0.75. Okay, so that will be coming somewhere 0.5 is here, half, and 3 by 4 will be somewhere here. So a 0 will be here, right? Since it is a complex 0, plus or minus complex 0, you will be having a conjugate 0 here also. Okay, so this is the pole 0 plot and Z transform and ROC of the signal.